refrigerated truck. So these boxes, they're going to give you rough load in here. 8 by 8 boxes like we have in there. 35-degree box, 6,000 BTU. Negative 10-degree box, 6,000 BTU. That's the amount, that's the heat load, that's the heat we need to remove. Off the top of my head, 6,000 BTU is a 3/4 horsepower right here. Right? And this is a 1.5. Alright?
If it's the same.
Yeah, why is that 1.5? Because of the temperature drop?
Because of the compression ratio? Or?
No, I'm gonna see AC 40-degree coil, 1 ton equal 12,000
BTUs.
which is 1 horsepower, right?
Yeah.
For medium temperature 25-degree coil, 1 ton equal 8,000 BTU, which is the same 1 horsepower, right?
Okay.
For low temp, negative 10 degree, negative 20 degree, 1 ton equal 4,000 BTU, which is 1 horsepower. The lower the temperature you go, the less heat you can remove. Okay, so that you have to.
So that's why that one's 1 and it's
So
1/4.
that's right. This is 3/4,
Yeah.
and that's 1.5.
One.
All right.
Mm-hmm.
So you'll be looking at me at 8 by 8 box. Why not use the same compressor? Right? That sounds right. I mean, it sounds
Right.
logical.
Sounds logical.
But look at the temperatures. You know, the temperature is lower, gets lower, there's less heat that you're able to remove from that thing. So that's why you need a 1 horsepower, because you need more refrigerant. Even though it's less heat, you need more refrigerant circulating in that system.
Compression rate.
So you need the BTUs, the horsepower rating to match your heat load. So, and this gives you, these are, quite honestly, this is industry standards. All right? So it's not just for this boat. He actually pulled this from some of the manufacturer's publication. Which is okay, he can use it anyway. He got permission to use it anyway. Huh?
I said it.
Yeah. Yeah, because before he published this book, when we had to review it, we check all those things. You know, see if he plagiarized or not.
But it's for education, you said they get the right teaching.
Yeah. You know, there are certain things other instructors in this school, certain materials they can use, that I can use. I'll give you guys. Because I got the permission already.
So,
You know? So,
give us some of it.
yeah, you are going to get something. There are certain things I can copy from certain texts or download and give to you guys as a teaching aid. You know? See, this is I think this MT is. You ever seen in that lab? There's a big blue compressor. Someplace in that lab.
No, I didn't see it.
It's called the manufacturer's Manurup or some crap like that. That's what this MT means, anyhow. I think. So that's their thing. 075 across the board, regardless who the compressor manufacturer is, represents 3/4 of a horsepower. 100 is 1, 150 is 1.5, 200 is 2 horsepower, 300 is 3 horsepower, and you go along the line like that. Yeah, it's here. Why the hell did I have to go? Now you see the BTU ratings for each, right?
Yeah.
3 horse is 24 and not 36. Because for an air conditioned unit, 3 horsepower give you 36,000 BTU.
You have 1 horsepower for 12,000, it's 1.5. So you want up that.
Right. So,
Yeah, because it's medium temperature. So it's 8,000 for 1 horsepower, and 1 ton is 8,000 instead of.
yeah, because as you go to the lower temperature range, as the suction temperature gets lower, pressure gets lower, therefore your compression ratio gets higher.
That's the
As
horsepower.
compression ratio gets higher, you have to pump more refrigerant to satisfy that distance between the suction and the discharge. So you need a mass flow rate.
It's open, right?
Now you see the same 3/4 horsepower, 4,000 BTU at negative 10 degree suction, and as I begin to go lower,
It's less.
it's less.
Even,
So one horsepower, I'll get 5,000 BTU. 4 down there. Well, I did have negative 20 is 4,000 BTU, right? Wasn't that what I had?
No,
You got,
Yeah, but it's 4,000 BTU. Now, if I slide right across here and I begin to increase this temperature, bring it into the positive range,
the BTUs go up.
the BTUs here will go up.
Okay.
All right? Because here's what happens as we go down here, the specific volume of your refrigerant changes. And as the specific volume changes, you will need to pump more refrigerant. So you need a bigger compressor to handle that, bring up the volume. Okay? And wish you guys go through that pressure enthalpy part of that book from the first or second chapter, I think it is. I'm not sure. You're going to see it actually on the diagram. So now we want to match evaporators with our condenser unit. This will be a medium evaporator, 040, which is 4,000 BTU, which is a half horsepower. But the thing is, manufacturers will normally give you this matchup, because you may go out there and figure that, this will work with that. But if it's not the same manufacturer stuff, and if you're not quite sure, let the guys who are selling it to you give it. Here's the deal. Whenever I buy a system, walk-in system, of course I will specify my box dimensions and what have you. And I tell them, the engineers, or the guys who are going to sell me this, hey, you now turn around and size me the condenser and evaporator unit. All right? So if there is a problem, they're the ones who size it, right? So I can return the whole thing, and they will upgrade it if it's necessary. So I prefer the mistake to be theirs, because I have the 1-year warranty.
Right, and it's their responsibility.
Right, and it's their responsibility at least for that year. And it works out good. But just in case that one odd time, you're protected. So I let them do all the sizing. Just say, hey, this is the box. Okay, now all they'll ask you, okay, are we bringing in pre-chilled product, and what type of product we using? What you store? Is it strictly meat, or do you have meat and vegetables? because each of those product has a different specific heat. And you guys know what the specific heat is, right? So that means you will need to calculate what the heat load is from your product. And there is a given heat load that comes off of the box itself from air infiltration. We have to know what kind of traffic we have through here. Is this a service walk-in or is it a storage walk-in? You know, storage walk-in is where you take out stuff you need for in the morning,
Right.
and you take it to your prep area for the little stock your little refrigerators. Service walk-in is where you're opening to get things to prepare, and that door would be more or less the amount of time it's open. In 1 hour, you may as well leave the door open permanently. Okay, and for those service walk-in is one of the reasons why now the health department requires that they put these plastic strips on the doors. They call them clear view doors. If you put them on, that opens up like this, saloon doors.
Yeah.
They call them clear view doors. They recommend you have that or have the hanging plastic strips because the doors are open so often that you get cross-contamination from whatever is in the kitchen or any other area into that box. So that is, regardless where the box is located now, that's one of the requirements. You have to put the plastic strips. Have to. So always figure for that because those things, regular strip is about $360. You don't want to lose that out of your profit. You know, so figure for that in your. No, we're not really concerned with this calculating temperature difference and evaporator sizes. Choosing a thermal expansion valve. Always match this to the capacity of the system. For example, if you go into a system, you know what the size of the condenser is. Let's say it's a 3/4. Then that would be 6,000 if it's a medium filter, 6,000 BTU. Then you need to get a thermal expansion valve that can handle a heat load that's 25% less than that rating, which would take you in the realm of about half horsepower or 4,000 BTU. 4,000 BTU. And you will be okay with that because regardless what the system is, the heat you absorb is 75% of the heat you reject. So your compressor, your condenser compressor unit is always size 25% larger than the heat load you have. That's to get rid of that excess heat.
Heat compression.
And that holds more or less true for air conditioning system, heat pump system, these systems. You know, at low temperature it's going to be slightly different. You know, these absorb low temperature here like -40, but more or less you calculate for about 25% difference. Right? You need to get rid
Heat compression.
Yeah, so bottom line is if I'm getting rid of 100,000 BTUs outside, I'm absorbing 75,000 only from inside. The 25 is where you pick up from the compressor running, heat to the
Suction line.
motor, suction line, heat.
line.
Yeah, you know, excessive superheat.
Yeah.
So it's always about that.
I just want a quick question. Are those super low temperature refrigerations that you said are like minus 120? Is there superheat in there?
Yeah, you still have.
What is it? What is it? How much is it?
Very close, maybe 1 degree.
1 degree, that would be the most probably, right?
Well, nobody. We're not going to make it 0.
Well, I understand, but you probably couldn't go any higher than 1, right?
We could, but you know, the lower the superheat, the more efficient the system. So why not bring it to this most efficient point of operation?
And they're all going to have
You
heat.
see that beacon? Remember I told about the beacon system with all those electric expansion valves?
That's what it was.
That
I bring down those boxes and I've been operating them at 1 degree superheat.
Yeah, you said you was gonna bring in a beacon, that's what you said.
That's, yeah, that's
the
right.
other
It is
thing
the
you said.
beacon, so-
Beacon. Yeah, I write it.
Yeah,
I write it down.
beacon and the,
That's it, but, so you would use an electronic
And the
control
power
system like that?
yeah, you see those, in order to get down to that superheat, or maintain 1 degree superheat, we really need electric control.
Right.
It's gotta be electronic or
It's the only
electric.
thing that's that accurate.
Yes, because mechanical valve, purely mechanical, that reacts to temperature change, it just ain't gonna cut it,
Right.
you know? Because you know what it is, you sense temperature here, and I need a mechanical movement proportionate to the temperature you sense in here. Hey, you better add a 20% or something to that, or subtract 20%.
So
It's
you would
never-
need the electric.
Yeah, it's why sometimes when the cops stop you and say you're speeding, you're gonna tell, my meter was showing exactly 55 miles an hour, how you clocked me at 60, but you have an analog meter.
Mhm.
The speedometer is analog. It's woefully freaking inaccurate.
Yeah.
Alright? Well, of course, their electronic thing could be out of
Calibration,
calibration, but you know,
You can make them prove it's
You got-
calculated too. And it even tells you, they're allowed to be within plus or minus 5 miles an hour. Off. So that ain't right either.
so, you know, in this little book they have, I think you guys did 204 where he has those rules of thumb thing.
Yeah.
Guys, it's okay if you want to use that. I'm not a firm believer in anybody telling me that this is rule of thumb. I make up my own rule of thumb and you should too. Nothing in this industry is written in stone. You have to work with what you have, and the environment that you're working in will determine what your final setting on these systems is going to be. You know, because if you're setting up one of these in an environment that goes from winter time 0 degrees to summertime 130 degrees, you need to set up your system to handle that 2 ranges. You know, you can't depend on somebody else's rule of thumb and you get screwed in the long run. You probably get the thumb. So, hot pull down boxes. So when we have boxes that need to pull down from room temperature to
Need to be double.
Huh?
Double.
yeah, if it is, you make sure you have it there so you can pull down product in shortest possible time. You don't want the product to spoil. So you kind of supersize the system. It's like if I have a floor box where I keep flowers, the 8x8 box we had there was 3/4 horsepower, right? Earlier. Now, if it's a florist box, I
Medium.
need to maintain a higher level of humidity. So I need to bring that temperature down
But
in a pretty shortest period of time I can. So what I do is supersize,
Make it larger.
make it larger. So instead of going 3/4 horsepower, I normally double on that.
So bring
I
it
make
down
my system
quicker.
1.5. So I drop the temperature from here to here.
Takes less humidity.
But you don't take all the humidity out.
So we don't remove humidity. The whole idea is not to remove humidity.
Okay.
Maintain humidity in the system. All right, so
It doesn't dry your product out, freeze and burn.
yes, and you don't want to dry out flowers. You know,
Right.
nobody wants roses that are dry.
That's potpourri. What's wrong with it?
No, but you want it fresh first. You make your own potpourri. You know, so yeah, that's it. But I don't want. You know, if it's Mother's Day, you say, I don't want to send my mother roses that smell like crap and look like crap.
True.
So, in case like that, you always double on the size, and what you do in that case too is move the air much more slow. You circulate the air at a lower rate, probably about half what a normal walk-in box will be. Okay, and I know that sounds contrary because typically, if you slow down the air across the coil, you remove more humidity.
And we're also
All right.
gonna cool it.
Were you taught that? In air conditioning system, one of the ways to remove more humidity is by slowing down the air volume
Slow
passing
the
across the
phase.
coil.
Yeah.
That can be proven mathematically too. Okay? If you use the P1, V1, T1 formula. Because you know P1, V1 over T1 always equal V2, V2 over T2, right?
I didn't know that. No, I've heard it.
Yeah, and if you use that formula, you can prove that the slower the air goes, the more humidity will be removed. But this sounds contrary. I'm slowing down my fan and I'm having higher humidity. I just contradict myself,
Yes,
right?
yes.
Yes, you did.
Yeah,
I
absolutely.
didn't get it.
But here is how it goes.
Because you're slowing the fan down to get more
Good, but
humidity.
you
when
see,
you're-
in this case, even though I did slow the fan down, I increased the capacity of the system.
Oh, it's cooling more.
Because
So,
you got a larger
because I
system.
have a larger system. And if I had a larger system and I slow down the fan, I'm going to retain humidity. Because I'm not going to be able to remove that much humidity because the temperature is coming down so fast
quick.
that humidity ain't got no time to sit on that coil. Or it will sweat, you know. And here's the thing now. With that humidity, if it's too much, I can put a, they have a humidity stat. I can put in there to power up what we call a reheat system. That raises the, deliberately raises the temperature of that box if the humidity is at a certain level so that the system can cut off and remove some of that humidity. So it's artificial load I'm introducing into the system in order to maintain a certain humidity. So I can do all of it in one walk-in box, all right, for different applications.
Definitely so much more you can do with refrigeration.
Sounds like
Yeah, you see here? Yeah, this
Sounds like it's
and
never ending.
The thing is, guys, with an air conditioning system, I check outdoor temperature,
Yeah, you can see these.
check that split, I check subcooling, I will check
Mhm.
indoor, I will check the split again, and I will check my superheat. If those four conditions fall right into where I need it to fall,
You're done.
I can put together everything and walk the hell off of that
Yeah.
job. With this,
Get your money first.
Well,
you gotta sit down there and do some kind of yoga or some meditation because you're gonna be sitting there for hours on end while you're doing adjustments to this. Okay?
Yeah,
Good.
long time.
So some of you guys, you may as well walk with the weed one, right? Yes, makes you pass the time, right?
Colombian gold one.
Oh.
Now, I'm not gonna get into this, guys, because this is the same.
Gotta be there for a while.
This is the same heat load calculations you guys will do for a structure when you're going to size an air conditioning system. See, I have heat transmission load ceiling, exposed wall here, floor thickness, type of material the floor is made of, type of material the wall is made of, the infiltration factor, the U factor of the wall,
Yeah.
and from the U factor, you can calculate the R factor. And just for your information, if your R factor is the reciprocal of the U factor. So if they give you R value, you can, and if somebody get brilliant and want you to say, hey, what's the U value? Hey, it's 1 over R. And if they give you the U value,
And
it's 1 over U is equal to R. So, yes, sir.
Is this test multiple choice for her?
Yeah, who do what?
This test.
Is it multiple choice?
For you?
Yeah.
No, it's going to be an essay test.
Yes.
Never pay attention. That means open book.
I'm very much tempted to give you guys an open book test.
That'd be good. Might as well give us an open book. That'd be good though.
All right?
That's like study.
Come to think of it, what do you guys think about that?
Open
I
book.
don't know. You know, who's actually gonna be tricky on that.
Cause you know they give open books as hard as a motherfucker.
Yeah.
Right, I'm telling you. That's
What do you got up your sleeve there?
Yeah, I'll tell you, that's true. Fuck
Yeah,
that.
it's definitely got something.
That shit sound good. That ain't right, bro.
I heard about
That shit
it,
ain't
man.
no shit. I ain't
I heard
fucking
about
with
One of his suffers.
that. You understand me?
I can give you 20 question exam
Still fuck you.
that you will pass with no sweat. I can also give you a 20 question exam as you sit here for 3 hours.
Dr. Smooth.
Yeah.
I have one question for you.
I can give you a
I'll take them on
test
first.
on 20 questions. And you'll be sitting here 4 hours and still be working on it, or I can give you 20 question open book test. I would say.
That shit like a school.
So,
Take the 1 hour. 1 hour you guys can work on this.
No sweat.
I could do it anyhow you guys wish. I'm here to please you.
No sweat.
We want the middle.
What do you say, the first one? I'll take the first
The
one.
middle.
We want to test on whatever you would, we want to test on the stuff
this?
that we were shown. Not on this, on the stuff
That
that we
shit,
were
yeah, I
shown.
don't know about that.
We want the
No,
middle.
no tricks.
How
No
you
tricks
give it to us
attached.
is how you
That's
give it
it.
to us.
No tricks attached.
Open book, that's it.
30, 40,
It
50.
ain't tricky.
Case
Got it.
closed.
You know,
Next
I'm
case.
multiplying if you read and you were following up on this, you know, should be easy. I mean, if I can pass the test, why you can't pass it?
Oh, I don't know about that.
You know?
Yeah. We're not asking for anything
You
easy.
don't get a difference.
So guys, this is
A mere site.
this is the same table you probably use to size a building
Yeah.
to calculate the heat load on a building. Alright?
You want a challenge?
I don't want it spoon fed though.
I want you to spoon feed me. Put a nipple on that bitch.
When you're going, if you're gonna be going pipe sizing, whatever pipe is on the condensing unit, whatever comes out and goes in, that's the length, that's its diameter you
Size pipe
need.
you use.
Yeah, so if it's a 5/8, 3/4 inch line set, that's what you buy.
Yeah, because the one we just did, the
One we just did,
the
they didn't even
condenser
match.
was 5/8 and the evaporator was 3/4.
Yeah.
Well, that means the evaporator is probably slightly oversized for that.
They do
condenser.
it to
Yeah.
raise it a half a seer. They've been given 3.5 ton
Yeah, but the other
condensing
units-
units and 4-ton evaporators, and they say it raises the seer value
From what?
from like
Who says
14.5.
that?
Blackman.
Blackman?
Yeah.
Blackman need a kick in it, but.
Yeah. They
The
said-
only way you can raise the seer value of a system
Yeah.
is by making the condenser coil
Oh, I
bigger,
know, and they use, but they said that.
but not the evaporator coil. If you make the
Not the
evaporator coil
coil.
bigger,
Well, that's.
Oh, that's what they did.
That's what they did.
Because if you had a matching evaporator coil, we would have had a 5/8 pipe on that.
Yeah, but
just
the
as
one
well
we
as the
put
condenser.
in, the one we put in
You're gonna
Chris's
start-
house was a 3.5 with the 4-ton, and it was
Right.
matching.
yeah, that would match.
I think that this guy was just an idiot, and Johnstone gave him. He just is
The
an
American
idiot. I
standard unit.
think that he was just an idiot,
All right, guys.
and he bought him at separate.
Let's wrap this up anyway.
Huh? It's a wrap. Stay strapped it down.
And those P-traps.
Hold on.
Test them.
The P-traps.
You guys know what P-trap traps, right?
Yes.
Yeah.
There is also
Yeah, the running P-trap. Yeah, it all right there. Same thing.
there is also a trap you can use if the P-trap can't work. It's called an S-trap. All right?
That's a trap.
Yes.
And that trap goes directly
So
down, right?
P-trap is that. S-trap is this.
Oh, that's what we used.
It's called a running P-trap.
No, that's the S trap that we
This
used
is the
the other
S-trap.
night.
It's called a running P-trap because we got a trap like that and it was called a running
You want it
P-trap.
left?
The one on the right.
It's a running trap.
This is what they call it. I don't
You got
know.
it left, right?
Yeah, no, the S&W calls it a running P-trap and we bought it. We were at.
What's the
Okay,
difference?
here's the deal.
What's the difference?
In those two, just a shape.
Yeah,
The thing is,
Same job?
You can use
Yeah, they
both.
do the same thing. The location of your system and the room you have will determine which one of those you use.
Okay.
Yeah.
It just,
They should really.
It's a really space thing. That's all.
There's a lot of shit. I said it should be more than one model.
They got the P-traps now with the eyes.
It's a lot of shit.
I can take this
The glass, no, that's what they sell.
I could make this here.
$27.
It's 600 more signatures, so you still wouldn't know half of the shit.
No, it's clear.
That's what I'm saying, that's what the thing is, this is a lot of stuff in one, this is a lot.
This is the most stuff I've like jammed up shit we've ever done before.
Yeah, this is a lot of information.
A lot.
Yeah,
A lot of it's gonna be hit and miss, Josh, you know what I mean? You go and you see some shit. but-
yeah, that's why I'm gonna give you a open.
Yeah, definitely.
Okay.
Alright, now, here's why these traps are important. See, this is on the roof, the condenser unit. This is down here. Oil travels with the refrigerant. We do not, that unit is too small for me to invest in an oil trap up there. So whenever the oil comes down here, it comes into this evaporator coil, and it's going to drain here. You put a P-trap, so the oil accumulates here. When this is filled, oh, I can write it. Yeah, I can write it. So I have the screen.
I know in the other school.
Why I think I always hit this to make sure there ain't no screen there. Because I was on the screen already and it can't
It's
even.
not that type of school.
You got the one with the pull-down one.
See, when the oil gets to that point, this sucks the oil back up into the compressor.
Negative.
Um,
You count that 6 before you
So what is the other trap for up there?
That's,
okay, I'll show you in a minute.
remember
Now,
you said if you get up,
in a case like this, I can still put the other trap in this area here. There's nothing to stop me from putting it, guys. The choice between that two is personal.
Okay,
Other than
space restriction.
space restriction and design restriction, it's a personal thing too.
right.
All right?
The only one that I've seen clear
Now,
is the other one.
Here's how this
Yeah, but
works.
this is, he's talking about, this is in the refrigeration.
I know.
part.
This will pull
Oil.
the oil up. But now, if this rooftop and here is
Is that copper?
over 10 feet, right?
You said you gotta add another one in.
Is it 10 feet?
You said
I normally,
10, you said 10.
Well, every store.
You said every 10. You said if you're gonna do it, you're gonna do it at every 10. I think you said that the other day.
yeah,
Definitely.
at 10 feet here and,
That's
You
a
know,
10
you said
inch.
you wanna go no
That's-
further than 10 feet if you're gonna do it.
That
you
says
do it at 10.
inches.
yeah,
That
each
says
10.
inches.
Huh?
You
10 inches, you
put,
put
you
it.
put the inch symbol. 10 feet.
10 feet.
Yeah.
Don't ever correct you in public.
No, you can do that. Sometimes you do, that's a typo.
A typo. Exactly.
He's trying to be like the
So,
book.
because the thing is, this tubing can be so big, the diameter can be so big that when it pulls this little oil, it just coats the side of this, and it's not going to get back up there, it's just going to drop down.
So you wanted to
So
catch
it traps
another
here
trap.
again, and then some more oil. So this may have to fill and pull twice to fill this one up,
Uh-huh.
and then it goes
Back
in the
into
last
the
trap.
right.
Now up here, you see I have a slope downward. Oh, come on. That's it. That's a Banford Hall guy. See this? It means when oil come here, you see the height there?
Uh-huh.
Yeah.
This here is higher than there, right? So oil can't come back down.
Right, I
Yeah.
got you.
Because sometimes it does tend, if you allow that compressor to have gone into a vacuum, means that line would have been at a vacuum and then it would suck some of that oil back through the suction to equalize pressure down here.
Yeah.
So you never want to run those compressors in a vacuum. That's
Right.
the one of
Never
the,
run
that's
it.
one of the reasons too. You always we get the oil coming out of them. All right. And you see here, he has this 20 feet, but there's no way I'm going to go 20 feet. All right. So this one, I think this is a typo. This one. But I ain't going 20 feet, guys.
You said that after a certain point you wouldn't go up anymore without like some
No,
kind of bump
because-
or something because
Because there is a limit to how much that can suck or how
Yeah.
high it can go.
Yeah,
And-
feet of head, right?
You know, they're probably designed maximum, maybe 15 feet ahead.
Yeah,
Or in this case, it's 15 feet of lift.
lift.
All right?
Right.
Right,
Head-
head would be on the discharge
Head would
side.
be on the high side.
What if you have a 20-foot ceiling though? That's the top of the roof up there, right?
Yeah.
Well, if this is 20 foot, you put this at this mark. And
10
then
feet.
right under here, you put the next one.
Every 10 feet.
So you put 2. And I prefer it this way with the 10 feet than 20 feet.
But if it's like 50 feet, do you put a pump?
What do you do?
Well, if it's 50 feet, rethink your location.
Oh, okay.
Or you have to double up on the size of that.
Or compressor.
Because
So,
whenever, just remember this here, whenever you remote a compressor, you're losing efficiency the farther you go. Alright? So the farther you go, the more efficiency you lose. So you have to increase horsepower to maintain efficiency at least. Because right here now we come back to the same thing, MFR, mass flow rate. Okay? Oh, and always remember you
so that's
insulate
only
this with,
needed in,
If the compressor is above-
compressor's above the evaporator.
Yes. and you put a reverse trap. Normally we put a reverse trap, which is this trap. Actually, no, not that one so much. This trap, turn upside down. You put that on top of, by the compressor right at the suction.
So these,
Instead of putting the slope, you can have this pipe coming straight, but you put that reverse trap. And
So
that,
it won't go
that
up.
go up, so the oil
Oil
will
won't
get
go
sucked.
up.
So,
so this is in the copper suction line.
yes, so
Okay.
you see you have quite a few options as to how to install this and make it work properly. Because, you know, neglecting to do this will cause that compressor to run out of oil and it's going to burn up or seize up. And here's what's going to happen now. You're going to put in a new compressor. Remember all the oil went out of that compressor?
Yeah.
You put in a new compressor,
Same
charge the
thing is gonna
system,
happen.
turn it on. 2 days after, you get a call, the box ain't working, it's hot. You go up there, you find the compressor broke. It's dead, right? And when you check, you find it has double the amount of oil. Because it sucked all the oil that the first compressor lost. It was in here, it sucked it back up. So now you overfill that compressor with oil. That
So before you hook it up, what are you gonna do, blow the lines out?
Yes. Cut down here
And
Let
blow it out?
Yeah.
and blow it out.
So anytime you see a system where the compressor's lost its oil, you're gonna have to blow it out.
Yes, and what you could do is, you know, put a little drain or some damn thing
Right.
here.
And the vacuum pump won't pull it.
Not that much, not unless it has the oil there where it can pull it.
Okay.
But if the oil is coating the side of the tube, it's not going to pull it out. Does that look familiar? That guy look familiar?
Never seen him.
Anyhow.
Who is that guy?
Why, is it red?
Alrighty. You see that there, guys?
Yeah, that's the trap.
You see? No, you see how they have that coil that's excess line set?
That's
Uh-huh.
what you're talking about. How you don't
You see
like
they
the
coil
line.
it like this, right?
Yeah.
If you're going to coil that excess line set, it's okay you coil it up and then lay it like this.
You're supposed to lay it horizontal.
Oh, yeah?
that's it.
Okay? Don't leave it like that, lay it like this.
How come they left it like that?
Because they're,
Amateurs. All right.
The
I just
expert.
wanted to,
Nah.
no,
Go ahead, say it.
Zach.
They're from Brantford. Go ahead.
No, no. They're it. I've seen worse than that. It wasn't the guys from Brantford. Some of the guys from Brantford are pretty decent compared to that crap here that we see up there sometimes. But we don't want it like that. It's okay you turn it flat if you don't want to cut the lines here.
But you said to cut it because the roof
Yeah, I will.
shit on
I
it.
mean, why do I want that? If the roofers go and do something to the roof, they start rocking that thing back and forth, it will crack something someplace along the line. They can kink it. And personally, I trip over some of them.
Yeah.
Alright? Yeah, you see the guys crying for the loop piping?
This is trap soil.
Yeah. Okay, we did do this in a big book, right? And I'm going to be very selective when I choose questions from this little book.
Okay.
Okay, I'm going to choose what I think is relevant question that we covered in class, right?
And other notes too that we've taken in class?
Yeah.